All right, let's take a look at section B now from this VJC 2022 paper 2. And in question number 5, we have all these probabilities that are given to us. And in part 1, we are supposed to find the probability of A intersect B prime. When we are given this piece of information here, the conditional probability. So in question number 5, in part 1, we are going to make use of this probability of A given B prime. This is equal to 0.55. So probability of A given B prime is also defined as probability of A intersect B prime divided by the probability of B prime. So this is equal to 0.55. And this is what the question wants us to find, the probability of A intersect B prime. So it is going to be equal to 0.55 multiplied by probability of B prime. And probability of B prime is 1 minus probability of B. So it is going to be 0.55 multiplied by 1 minus probability of B is given to us as 0.2. So my answer here is 0.44. This is part 1. It's a super easy part. It is going to be carrying just 1 mark. Part 2. In part 2, we are supposed to find out about the probability of A prime intersect B prime. The probability of A prime intersect B prime can also be perceived on our Venn diagram. Let me just draw a quick diagram to represent this. For example, let's say this is A, and here this is B. So we are looking at a region that is both outside A and outside B at the same time, so it is going to be this region here. Okay, we are going to try to find the probability by working out this area. So from the previous part, this 0.44 is probability of A intersect B prime. So if I were to try draw the same two circles again as this, A intersect B prime is whatever that is inside A and outside B at the same time. So we see that it is going to be this region over here. So this region here is 0.44. And we do know what is the probability of B, right? The probability of B was given to us by the question as 0.22. So what we can try do is to take this entire thing, which is 1, minus away this region here, and then minus away probability of B, and that will give us this shaded region here, right? So it's going to be minusing away this region. So it is going to be 0.44. Then I will also minus away the probability of B. Let me just write down the probabilities that I'm trying to minus off. So I'm going to minus off this probability of A intersect B prime, and also minus away this, okay, this region here. So this region here is probability of B. So I'm actually trying to minus away this entire region here right now. So this will be 1 minus 0.44 minus away probability of B. This is given to us by the question as 0.2. So this will get me my answer for part 2, 0.36. Let's move on. Let's take a look at the last part of this question number 5. So in this very last part of question number 5, we are given probability of C, and we are also given, on top of the two events that we were given previously, okay, A and B, we are now also given the probability of C. And okay, we are given more information. We are given that probability of C is equal to this. We are given probability of A intersect C is equal to probability of B intersect C. And we are also given this probability of A prime intersect B prime intersect C. And we are also given this. Let's just try to consolidate all these pieces of information that are given to me as on a Venn diagram. Okay, let's do that. So let me try to do a sketch of the Venn diagram. We have 3 circles now. So let's say here we have A, and let's say this is B, and here this is going to be C. So the information that is given to me is PC is equal to 0.4. So this entire circle here will represent the probability of C, and PA intersect C is equal to PA intersect PB intersect C. This I think we can indicate it on this Venn diagram here. PA prime intersect B prime intersect C. Something that must be outside A and outside B and inside C is equal to 0.24. So the region that is outside A and outside B and inside C is going to be this region here. So this region here is 0.24. Okay, so let me just indicate this. This is probability of a region that is outside A and outside B and inside C at the same time. And we also told one more piece of information, which is probability of A intersect B intersect C is equal to 0.1. And that is going to be this region here. So this region here is 0.1. Let me write it down here. So we have this region as probability of A intersect B intersect C. Okay, we have this. And we are supposed to determine whether A and C are independent. So, okay, in order for me to determine whether they are independent, I'm going to try to verify whether this is true. So, if A and C are independent, that means probability of A intersect C, it should be equal to the probability of A multiplied by the probability of C. So, numerically, this must be true in order for A and B to be independent. Let's just work out the simpler one first for both, for this left and right hand side here. Let's try this because the information is readily available to us. So it is the probability of A multiplied by the probability of C. Probability of A was given to us in the previous part, and that was 0.6. So it is going to be 0.6 multiplied by the probability of C. Probability of C is given to us now as 0.4. So here is 0.4. This is equal to 0.24. So now let's try to check whether probability of A intersect C is also going to be equal to this 0.4. If it is not, then A and B are not independent. If it is, then A and C. If it is not, then A and C are not independent. If it is, then A and C are independent. And probability of A intersect C is going to be this region here. So we're going to try to make use of the information to calculate for this area. So with the information that is given to us, there's still one more that we can actually make use of, which is this. Probability of A intersect C is equal to probability of B intersect C. So it is given to me that probability of A intersect B is equal to the probability of, this is B intersect C. Well, in fact, I think by logical deduction, we can really tell that this area and this area, they are exactly the same, right? Because of this. Okay, but we can also calculate it mathematically. Let's say this area here is X. Let's say this area here is Y. That means probability of A intersect B is going to be this, which is going to be X plus 0.1. And probability of B intersect C is this, which is equal to 0.1 plus Y. So X is going to be equal to Y. So this here is actually X also, which means that since I'm also given the probability of C, this is given to us by the question as 0.4, and probability of C is all this being added together, which is going to be this 0.1 plus X plus Y, which is now we know that it is also X, then plus 0.24, this is equal to 0.4. So 2X here, this is equal to, 2X here is equal to 0.06. So X is going to be equal to 0.03. So now we know X is equal to 0.03 and probability of A intersect C is going to be equal to this X plus 0.1. So it's going to be 0.03 plus 0.1. This is equal to 0.13. And numerically, it is not the same as probability of A multiplied by the probability of C. So therefore, we can now conclude based on this comparison that A and C are not independent. Okay, now we can move on to the next one, question number 6. Okay, in question number 6 here, we are given 4 digits, 3, 4, 5, 6, 7, and they are going to form a 4-figure number. So this actually says that for each of the digit that is in a number, they can be repeating. Okay, because this 4-figure number is going to be made of either of this 1, 2, 3, 4, 5 digits. Okay, so it is possible for the digit to be repeating. That is why in part 1, they can actually ask this. Okay, if not, I mean, we don't even have an option. So now part 1, they want the version such that none of the digits are going to be repeating. So if none of the digits are repeating, that means out of this 1, 2, 3, 4, 5, oops, there's one more, so 8. Okay, so out of these 6 digits that are given to us, so 1, 2, 3, 4, 5, 6, we want just 4 unique digits. So out of 6, we are going to choose 4 digits to be arranged here. And to arrange these 4 unique digits, it is going to be 4 factorial. And this will give us our answer of 360. Next, part 2. Part 2, okay, we want to find the number of different 4-digit numbers such that there is at least one repeated digit, but no digit appears more than twice in the number. There must be at least one repeated digit, and no digit must appear more than twice in the number. So there are actually 2 cases. Let me write them down. So case 1 and case 2. Okay, I can think of these 2 possible cases where there are going to be at least one repeated digit, but no digit appears more than twice in a number. So let me give you an example for this case 1 that I'm thinking of. Let's say the number that I've chosen that is repeating more than 1 time, but not more than 2 times, is the number 3. So a possible 4-figure number that I can be thinking of is like 3, 3, let's say 4, 5. Okay, so we have a number that is repeating. So we have at least one number that is repeating, but no number is going to be repeating more than 2 times. No digit is going to be appearing more than 2 times in this 4-digit number. So we are looking at a combination of, like, for example, AA, then the other 2 digits are different. So let me use alphabet. So AA, B, C, which means that for the digit that is repeating, we have 6 options, right? Because we have 1, 2, 3, 4, 5, 6. So out of 6 digits, I'm going to choose 1 digit, and this is going to be the digit that is going to be repeating. And we need 2 other digits. So we have already chosen 1 digit, so we will have 5 other digits left to choose from. And of these 5 digits, I'm going to choose 2 unique ones for the other 2 numbers. And now we have one of the digits that is going to be the one that is going to be repeating. The other 2 digits will just be there as the 2 other unique numbers. And if I were to arrange this, it is going to be 4 factorial divided by, because there are 2 digits that are identical, so divided by 2 factorial. This is equal to 720 for this particular case. And the other one that I'm thinking of that can happen in order for it to satisfy the condition that is given, which is at least one digit is going to be repeating, and no digit is going to appear more than twice. So it can be a number that is like 3, 3, 4, 4. Of course, like 7, 7, 8, 8, like 5, 5, 7, 7, all these are the possible combination, which means that in this here, we are looking at a combination of 2 digits the same, and the other 2 digits, they are also going to be the same, which means that the 4-figure number is going to be consisting of just 2 unique digits in order for this to be happening. Really? So out of 6, we're going to choose 2 digits. And these 2 digits are going to be giving us the 4-figure number. So when we are arranging these 2 digits where one of the digits is repeating, the other digit is repeating also, it is going to be a 4 factorial divided by 2 identical, so 2 factorial. The other 2 will also be identical, 2 factorial. This gives us a 90. Okay, these are the only 2 cases that will satisfy the condition that is told to us by the question. So the total number of ways that we are working on is going to be equal to 720 plus 90. The answer is 810. And part 3. Part 3 is, I think part 3 is challenging. Let's take a look at part 3 together. According to the question for part 3, we are looking at this 4-figure digit number such that no digit may appear more than once in the number. So, I mean, if no digits appears more than 1 in the number, we actually have the answer already, right, from part 1. And part 1, we have gotten a 360. So we have this, but then the question added another condition. The other condition is that this number is not, this 4-figure number, it is not divisible by 6. And I think this second condition is making this question very difficult to be done during the exam, because there's a lot of manual work that is involved. Okay, let me show you how it can be done first. So the number of ways for this to happen, is going to be, I'm going to take 360, and this is obtained from part 1, where no digits are repeating. Then I'll minus away the case where no digits are repeating and the number is divisible by 6, because what we want to be left with are numbers that are not divisible by 6. And what you actually need to do, right, to come up with this portion is to actually list down all the possible combination such that the total, the sum of the digits is divisible by 6. Okay, we are going to manually list down all the possible combination such that the sum of the digits is going to be divisible by 6. And I mean, I've already worked on this, so I do know what are the possible cases. So just to share with you the possible cases that will be happening here, right? Numbers that are a number that consists of unique digits and it is divisible by 6. It can be like, for example here, right? It can be like the number 3 plus the number 4 plus the number 5 plus the number 6. This is going to give us an 18, and this is divisible by 6. Okay, so we are actually going to try to look at this 3, 4, 5, 6, 7, 8, and then just keep trying to find out the possible sum of any of the 4 digits here, right? Such that the total is going to be divisible by 6. The other one, I'm going to write down for you. The other one is this 3 plus 6 plus 7 plus 8. This is going to give us 24. 24 is divisible by 6. And if you were to just try hard enough, right, there's just one more possible case, and that is 4 plus 5 plus 7 plus 8. This will also give us 24. So there are actually 3 possible cases, like no matter how you try to combine the numbers together, such that the digits are going to be divisible by 6. So I'm going to minus away these 3 cases. So there are 3 of them, so it's going to be 3, and 3, 4, 5, 6. You know, there are 3, 6, 7, 8, and this, right? They are all unique numbers. So arranging them individually is going to be just simply a 4 factorial. And this will actually give us our answer 288. And I think this is very difficult to be done in the exam because there is a lot of manual thinking work that is involved, where especially we want to filter out these 3 possible cases. I mean, if you try to list down all the cases where it is divisible by 6 and unique numbers, right, unique digits, right, I think it is going to be even worse. Okay, so doing a complement is definitely better. But I was trying to read the solution from VJC. They do give a suggestion which is pretty cool. I'm going to show you their suggestion, but I don't think it is actually easy to actually exercise what they have suggested, which is the best, I guess, okay, in the exam. So I don't think the suggestion is actually very practical, but it's still cool. I'm going to share with you what I've read from VJC's solution. So what VJC did was they tried to analyze, okay, the way the digits are being summed together. The smallest possible version that the digits are going to be summed together will involve, of course, the smallest 4 numbers. So it will be this. Okay, and this we have already gotten it. It is going to be equal to 18. And the largest possible number that we can get by summing the numbers together will be this, taking 5 plus 6 plus 7 plus 8. And if you were to sum these numbers together, this is going to get you a 26, and this is not divisible by 6. But what we can then deduce from this smallest possible sum and the largest possible sum is that all the rest of the combinations will be between the numbers 18, the sum will be between the number 18 and the number 26. And between the number 18 all the way until 26, there are only two numbers that are going to be divisible by 6, right? One is definitely 18. The other number is going to be equal to 24. So no matter how I try to sum, I will only be looking for the sum that is 18 or 24. The rest are all not divisible by 6. And if you just look at 18, or you can also look at 26. For example, let's look at 26. It's easy, okay? So to get a 24, with this sum, the maximum possible sum is 26. So in order to get a 24, we just need to minus 2 on both the left and right hand side. Then I'll be getting a 24, right? So for example, here I am planning to minus 2 in order for me to get a 24, which means that on the right hand side, I will also do a minus 2. And you think about it, okay? If I were to take 8 minus 2, what will I be getting? I'll be getting 6. So I will be needing a 5, 6, 7, 6. And this is not possible because the question wants the digits to be non-repeating. So taking 8 minus 2 is not a good idea to get a 24 because this will give us a 24, which is what we want. How about taking 7 minus 2? It is so not good because 7 minus 2 is going to be equal to 5, which means that I will be looking at a combination of 5, 6, 5, 8. That's repeating. Not what the question wants. If I were to take 6 minus away a 2, I'm going to be getting a 4. So it will be a 5 plus 4 plus 7 plus 8. This is equal to 24. And this is good because we have unique numbers, we have unique digits, and I'm going to be getting a number where the individual digits are going to be added to be equal to 24, which is equal to this case actually, right? 4, 5, 7, 8. So it is going to be actually this case. So we have gotten 1. Another one is take 5 minus away 2, which will be giving us 5 minus 2 is going to be equal to 3. So 3 plus 6 plus 7 plus 8. This is also going to be equal to 24, which is this case that is here. And this is also good. Okay, so this is what VJC has suggested in their solution to try to filter out those cases which are divisible by 6, which, like what I was telling you, I do think that it is a very cool way to filter out numbers that are divisible by 6, but I seriously don't think it is a very practical suggestion because I also don't think during the exam you actually have that much time to try to plan a strategy that is like this. So no matter what, I do think that this part 3 is not going to be easy to be done in an exam. Okay, let's move on. Let's take a look at question number 7. So in question number 7, we are looking at a yellow dice, yellow unbiased dice, and a green unbiased dice. And the faces, the numbers that are labeled on the faces, they are given to us according to the information that is given. And we are actually looking at a random variable x, which represents half of the difference between the score of the green die and the yellow die. Okay, so the word difference here is indicating to us that it is the absolute difference. Okay, so it will always be a positive number. So we are going to try to find the expectation of x and the variance of x. To do that, let's try to build for ourselves the probability distribution table first. So we have two dice, and they are going to be the numbers that is going to be appearing are going to be combined together in the way that is described to us by the question. So I think what I'm going to try to do is to build for myself a grid to look at all the possible cases. So we are going to be looking at yellow dice, and the other one is what? The other one is a green dice. And according to what the question says, for the 6 faces that are on this yellow color dice, 2 of them are labeled 10. So let me just write it down. 10. The other one is also 10. And 2 of them are labeled 30. So it is going to be 30 and then 30. The other 2 are labeled 50. So we have a 50 and a 50. Okay, so we have this. For the green die, 4 of the faces are labeled 60. So the first face is 60, the next one 60, then after that 60, and we have one more 60. And we have 2 more faces. One will be 80. So 80. The other one is going to be 100. And I'm going to list down all the possible x's here. Okay, and x is the half of the difference that is appearing on the 2 dice. So half of the difference, for example, 60, 10, the difference is 50. 50 divided by 2 is going to be giving us a 25. Okay, just in case you have missed it, let me just very quickly write down how I've gotten this 25, which is going to be obtained by doing a modulus of 60 minus 10 divided by 2. Okay, this gives us a 25. So similarly, 60, 10, this is going to be giving us a difference of 50, 50 divided by 2, so this is also 25. In fact, this is 25, 25, 25, 25, this will also be 25, 25. 6, 30, the difference is 30 divided by 2 is 15. So we have a 15, same for this, 15, 15, 15, 15, 15, 15, 15. And 50, 6 and 50, the difference is 10. 10 divided by 2 is going to be equal to 5. So we have a 5, 5, 5, 5, 5, 5, 5, 5. And 80, 10, the difference is 70 divided by 2 is 35. So we have a 35 here and a 35 here. This 80, 30, the difference is 50 divided by 2 is 25. So this is 25 here and 25. 80, 50, the difference is 30 divided by 2 is 15. So we have a 15, 15. 110, difference is 90 divided by 2. This is 45, 45. This will be 70 divided by 2. So this will be 35, 35. And this, the difference is 50 divided by 2. It is going to be equal to 25, 25. And now let us try to write down the probability distribution for x, where this here will be the probability when x is equal to x. So all the possible x's that we can see, right, will be like 5, 15, 25, 35, and 45. Let me write it down. So we have 5, 15, 25, 35, and 45. And now let's count. So 5, there are 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's no more. So it is going to be 8 over 36, okay, which is equal to 2 over 9. And 15, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a 10 over 36. And this will be simplified to a 5 over 18. 25, let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have a 12 over 36, which is going to be simplified to 1 over 3. 35, let's count again. 1, 2, 3, 4. So we have a 4 over 36, which will be simplified to 1 over 9. And 45, we only have 2, right? Yeah, it's only these 2. So it's going to be 2 over 36, which is going to be simplified to 1 over 18. So now we have our probability distribution table. I guess the next part is going to be easy to find the expectation of x. This is going to be sum of all the x's multiplied by the corresponding probability. So the summation of x multiplied by its probability will be 5 multiplied by this or this. Okay, doesn't really matter. So let's go for 5 multiplied by this, simpler. So 2 over 9 plus then 15 multiplied by the corresponding probability when it happens. So it is 5 over 18 plus 25 multiplied by 1 over 3 plus 35 multiplied by 1 over 9, and finally 45 multiplied by 1 over 18. So the expectation for x is going to be equal to 20. Next, we are going to try to find the variance for x. And to find the variance for x, let us first find the variance, the expectation of x squared. So this is going to be summation of x squared multiplied by the probability that x is equal to x. And this is equal to 5 squared, 2 over 9 plus, this is going to be 15 squared, 5 over 18 plus 25 squared, 1 over 3, 35 square, 1 over 9, and 45 square, 1 over 18. This is going to be getting us a 5, 2, 5. And now we can work on the variance. The variance of x is going to be the expectation of x squared minus away the expectation of x, and this entire thing here square. So it is going to be equal to 5, 2, 5 minus away 20 square, and this will give us our answer 1, 2, 5. This is part 1. Let's move on to part 2. Okay, according to what the question says, in part 2, we are going to be having another dice. This is a blue dice. And for this blue dice that is given to me, blue dice, the numbers are going to be equal to replacing the yellow dice. Okay, we are going to be replacing the yellow dice by this blue dice. The numbers that are given to me is, they are 15 and then 35. Okay, there are two 15 and there are two 35 and there are also going to be two 55s. So we have this. Okay, the yellow one is going to be replaced by the blue one. And we can see that actually this number, 15, is 10 plus 5. So we have a 10 plus 5 is equal to 15. And 35 here is actually a 30 plus 5. And 55 is a 50 plus 5. So the blue dice number is actually related to the yellow dice. Okay, I'm going to just write down as a shorthand for myself. Okay, so I'm seeing here which is blue. Okay, I'm going to just use B. Okay, so blue plus 5. Okay, not blue plus 5. It is yellow plus 5 is going to be equal to blue. So blue is equal to yellow plus 5. Okay, and what is X that is here? X, okay, this is a bit confusing. Let me change my writing again. Okay, so instead of using the alphabet blue, I think let me just write down the full word. So blue is going to be equal to yellow plus 5. And the reason why I'm saying this is confusing is because here I'm going to use an alphabet X. So X here, so X represents the random variable that is given to us, right? So according to the question, X is calculated as the difference between the yellow and the green dice. Okay, and it is going to be calculated as the difference and half of it. So it is actually the modulus of yellow dice and the green dice. Then we're going to halve it. We get the difference. So we're going to be doing a mod to this, and we're going to halve this. Okay, but if you were to observe the numbers that are given to you, right? Yellow and green dice, all the numbers in the yellow dice are actually all less than the numbers that are going to be appearing on the green dice. So if we are talking about modulus, okay, since all the numbers that is in the yellow are going to be less than the numbers that is on the green, we can also rewrite this as just simply without the modulus, if we were to just take any green number minus away the yellow number, we're going to be getting that positive difference anyway. Okay, so I'm going to remove the modulus and writing it as just simply green minus yellow, because any number that is in green minus any number that is in yellow is going to be positive. So it's going to be this divided by 2. So X is equal to this. And then I'm going to define W. Okay, W, okay, we don't really need to define because W is already given here, right? W is the difference between the blue dice and the green dice. Okay, so it is the blue dice and the green dice, the difference between them. Then we are going to halve it also. Okay, and what we can also see is that all the numbers that is from the blue dice, they are less than all the possible numbers that are on the green dice. So this is going to be the same thing. I can just simply write it as green minus blue divided by 2, and that is going to represent W. But we know what is blue. Blue is going to be yellow plus 5. So it is like green minus away blue, which is all the yellow numbers that is appearing on the yellow dice, plus 5. Then this is going to be divided by 2, which we can also rewrite this as green minus yellow divided by 2 minus. So here, minus 5 over 2. So minus 5 over 2 here. And what is green minus yellow? What is green minus yellow divided by 2? It is X. So W is actually just simply X minus 5 over 2. And this is why this is why the question can actually ask us for the expectation of W without having to actually go through the detail. We can just try to find the relationship between W and X, which we have found it now, to work out the expectation of W, because expectation of W is going to be equal to expectation of X minus 5 over 2. So the relationship between expectation of W and expectation of X is expectation of W is expectation of X minus away 5/2. Similarly, we can try to work out the relationship between the variance of W and the variance of X. So variance of W is going to be the variance of W is equal to X minus 5/2. So what is the variance of W? It is just simply going to be the same as the variance of X. So this answers for me part 2 of the question. We can move on to the next one. Question number 8. Let's see what it is. Okay, question number 8 here. This is this is a long question. So question number 8 here, we have a correlation linear regression question. So in question number 8, we are given this agricultural experiment that is carried out to study the effect of a certain fertilizer on the growth of seedlings. The fertilizer is applied at various concentration to a random sample of 10 plots of land, and the seeds are sown, and 2 weeks later the mean height of the seed is going to be measured, and that is Y. So the concentration of fertilizer is X and the mean height of the seedling is Y. And something that we have always been talking about in our tuition class is that when you are looking at a question, regardless of how the question is going to be continuing, from the very beginning, if it is possible for you to identify a very obvious independent data and a dependent data, you should take note of that, okay? Because that is how the entire experiment is being carried out, and that is how any regression line is supposed to be defined with respect to. So if you were to read this question over here, we can see a very obvious independent and dependent data, right? Because the fertilizer is being applied. So the fertilizer is introduced into the experiment. So it is the data that is independent of the experiment. So let's just write it down here to let ourselves know, okay? So X, according to the way that the experiment is being carried out, it is the concentration of the fertilizer, and this is independent of the experiment. So it is the independent data. And as for Y, Y is the output from the experiment. It depends on the experiment itself, the height of the mean height of the seedling. So for Y, we can see this is the dependent data. Okay, so this is defined for us by the question already. So we want to make sure that as we are doing this question, we respect this relationship that is given to us, okay? So in part 1, we are supposed to draw the scatter diagram. We're going to make use of our graphing calculator. So here, okay, let's try to take a look at how the scatter diagram is going to look like. We're going to press stats, we're going to press edit, and I'm going to plant all the, okay, there's some data here, I'm going to remove them first. So I'm going to plant all the X into L1 and Y into L2. Let me just also indicate to myself what are going to be inside my L1 and L2. So I will be looking at L1 and I'll be looking at L2. So X I'm going to put into L1 and Y I'm going to put into L2. So let's start. So for L1, we have a 5. Then after that, a 10. Okay, I've keyed in the data. Now let us try to use our graphing calculator to help us get a overview of the scatter diagram first. So we're going to go to second Y equal to turn on our stats plot. So I'm going to turn it on. Then after I've turned it on, I'm going to go to zoom and we're going to try to choose zoom stat. Okay, so number 9, zoom stat. Okay, so this is our scatter diagram of X versus Y. Let me do a sketch of it here. Okay, so this is my scatter diagram, and we do want to try to indicate the lowest and the smallest possible X and Y, and the highest and the maximum X and Y. So this is going to be the point that I'm going to be indicating. This point here will have a coordinates of 5 and 4.2. And as for the maximum possible X and Y, it is going to be this point here. So X is 90 and Y is 26.2. Okay, this is my scatter diagram, and I've labeled the axis. Let's move on, part 2. Part 2, let's see the question again. Okay, so for part 2, it is thought that the mean height of the seedling Y is modeled by one of the formula that is given to us. for y and x. So we have a linear one, the other one is a logarithmic version. We want to try to find the product moment correlation coefficient between x and y. So for x and y, which is this model, a linear model, applying it directly. So we're going to go here, we're going to go to stats. We're going to try to calculate linear regression line. I'm going to use number 8 because our formula sheet used A and B instead of A, B here. So let me press for number 8. List x list, I'm going to let it be L1, y list, I'll let it be L2. Let's try to calculate all this. I'm going to leave it empty. Let's try to calculate for the product moment correlation coefficient, and we get no product moment correlation coefficient. When we have a situation that is like this, what should we do? We will press for mode. And in mode, I'm going to try to turn on statistics diagnostic, which is here. Okay, it is now currently off. That is why we don't see the product moment correlation appearing. So I'm going to turn it on. Okay, this will sometimes happen when we reset our calculator. Okay, so I've turned it on already. I'm going to go back here again, calculate. I'm going to go for number 8. So now we are going to try to do a calculation again. And just to double check, x list is going to be x that I'm planting in, and y list is going to be y I'm planting in, and x is in L1 and y is going to be in L2. So we are doing it correctly. So here, let's do a calculation again, and now we have R. So for A, we have R to be equal to this 0.9256, and this is for, let me just indicate it here, this is for x and y. Okay, this is given to, this is requested from us by the question. So we have this, and we're going to look at another one, which is ln x and y. So we have x and we have y, we don't have a ln x. I'm going to try to generate another column with a ln x. So my calculator, let's go for stats, edit. In L3, this is where I'm going to try to generate L3. So let me indicate it here. So for L3, it is going to be ln x. Okay, a table that is like this is especially useful for myself. I also recommend that you guys try to adopt a table that is like this so that it's easier for you to know what exactly is inside your calculator. So in L3, I'm going to do a ln x, and x is in L1, right? I can just always refer back to the table. So from here, we're going to move our cursor to L3, and I'm going to type it as ln L1. So second button number 1, ln L1. This will help me to populate L3 with all the ln x. And now I'm going to go to stats again and do a calculation using number 8. And this time x list is going to be L3, which is all the ln x. Y list is still going to be L2, which is the y. So let's try to calculate this version for the product moment correlation coefficient. And we get a pretty good product moment correlation coefficient. So for part B, which is, let me write it down also. For part B, we are looking at ln x and y. Okay, and for this, we are getting a R is equal to a 0.996624. Let's see, the question 4 decimal places. So we have this. And then let's move on to part 3. Use your answer to part 1, scatter diagram, and part 2, product moment correlation coefficient. We are supposed to explain which one? X, y, which is y is equal to a plus bx. And the other one, y is equal to c plus d ln x. Which one do you think is going to be a better model? We can tell, right, this is going to be a better model because the product moment correlation coefficient is nearer to 1. And at the same time, from the scatter diagram, we can see that the curve actually synchronized more to a y on ln x kind of situation. Right? So not y on ln x, due to a y is equal to ln x kind of situation. So because for this, y and ln x, okay, a ln x graph is going to be like that. Okay, if this is y is just simply ln x. And of course, with the C and the D, it is just going to be linear transformation of this graph, which can potentially still look exactly the same as this, almost similar to this, not exactly the same, similar to this. And this, for this version, synchronized more to what we see on the scatter diagram. Okay, it is further away from this because this is actually a linear line, and I don't see it being a linear line here. So I'm going to try to describe this. Let me write down my description, my explanation here. So in my answer here, I have tried to highlight the two things that we have just mentioned. One is taking reference to the scatter diagram, which lead us to being able to observe that the relationship that we are seeing is closer to this version instead of this version. And from part two is actually pretty obvious because numerically, the value of the product moment correlation for part B, which is representing this model, is the one that is going to be closer to 1. So since both tells me that this is a better model, that is why y is equal to c plus d ln x is the better model that we are going to be choosing. And next, part 4. In part 4, explain why neither the regression line of x on y nor the regression line of ln x on y should be used. Okay, this is what we have already seen from the very beginning, which we are going to then apply to this question here, because the question is asking for x on y, and the other one is ln x on y. Okay, why is it that both of these are not going to be suitable to be used to try to predict the value of x for the given y? Y is given to us as 20.0 in this part of the question. So, I mean, by right, theoretically, having a x on y or ln x on y is better, because for these two for these two relationship, it is meant for us to be predicting x for the given y. Okay, but if it is this, then which is the independent and which is the dependent? If it is this version, right, x on y, that means x is going to be the independent and y is going to be the dependent. Similarly for this, ln x is going to be the independent and y is going to be the dependent. But from what we have analyzed since the very beginning, we have already deduced based on the information that is given to us by the question that x is supposed to be the independent. Y is supposed to be the dependent. Oops, I have written it wrongly. So I meant to say that x is supposed to be the one that is dependent. Okay, because x depends on y. So x, if it is this version here, then x is supposed to be the dependent. If it is this version here, x is supposed to be the dependent and y is supposed to be the independent. So we are using this to predict x for the given y. We can also use this to predict x for the given y. But the experiment is being carried out with x as the independent. So using these two equations, using these two relationship, they are making x as the dependent and y as the independent, which goes against how this experiment is being carried out. That is why we cannot use either of this. Okay, we got to use one that is where x is going to be the independent and y is going to be the dependent. So let me write down my version, my explanation here. Okay, so this part 4 here, it is my version. Okay, based on the same explanation, which I make a little bit of mistake just now as I try to describe to you guys. We need something where x is supposed to be the independent, okay? But the two versions that are given to us have both x and then ln x as the dependent. Okay, that is why we cannot be using either of these two to help us to do any prediction, because it goes against what how the experiment is being carried out. Next, part 5. So in part 5, we are supposed to find the equation of a suitable regression line. So it must be one where x is the independent and y is the dependent. And from the previous one that we have talked about, we are going to be choosing this model, right? This is the model where x is the independent, ln x in this case, and y is the dependent. And the regression line that we are looking for is this. So let me write it down. So the regression line from our graphing calculator will be y is equal to AA is this. So y is equal to negative 8.4492, then plus b is 7.8126, then ln x. So this is the regression line. For my answer, I'm going to try to go for 3 significant figures for the coefficient. So which I'm going to go for this. Y is equal to negative 8.45 plus 7.82 of 7.81 of ln x. So here 7.81 of ln x, and we're going to try to use this to find the required estimate, and that is when y is equal to 20.0. We are going to try to estimate the value for x. So y is equal to 20.0, that means negative 8.45 plus 7.81 ln of x. Okay, we should use the 5 significant figures version. Let me use this version. So negative 8.4492 plus 7.8126 ln x. This is going to be equal to y, which is 20.0. So ln x here is going to be equal to 20.0 plus 8.4492 divided by 7.8126. And if you were to try to calculate for x, x is going to be equal to 38.149. And let's take a look at the question. For the question here, x are all integers. So I'm going to go for the same rounding off as what the question has been, like the data that is given to us by the question. So I'm going to go for an integer value for x or so. So it's going to be equal to 38. And part 6. Part 6. Rewriting our equation in part 5, we are supposed to do that so that it can be used when y is which is the mean height of the seedling, is given in mm. Let's take a look again at the information. Y is given to us in cm, and now we want to go for y to be given to us in mm. How do we convert cm to mm? So for example, if we have a 3 cm is going to be equal to 30 mm. All right, I just need to take 3 times 10. So if I were to go for a version that is in cm, which is what we have here. So we have this. We have this y is equal to minus 8.4492 plus 7.8126 ln x, and this is in cm. So if we are going for mm, just like this, we will take cm multiplied by 10, right? So if we are going for mm, it is going to be 10 times of y is equal to times 10 minus 84.492 plus 78.126 ln x. And this time it is going to be in mm. So this can actually be made use of to help me to find mm. So it is actually supposed to look like this, okay? Because 10y, it is in mm now, right? So it's like w. So w is going to be in mm. So this is negative 84.492 plus 78.126 ln x. It is in mm. It is an mm. So w is equal to this 10y, okay? But this question is a little bit confusing because they're using the same notation y. Okay, but the question has already used y for cm, right? So it's a bit confusing. We are supposed to use back the same notation y. So I guess no choice. We are going to assume this w is equal to y, okay? So what is the version of the correlation linear regression line when y represents mm? And that means y, instead of this y here, which is in cm, right? Y will now be like w, okay? So y is going to be equal to this multiplied by 10. So it's going to be 10 multiplied by the original correlation linear regression line. So negative 8.4492 plus 7.8126 ln x, which tells me that the linear regression line that can help us to work on the mean height of the seedling to be in mm will be this multiplied by 10. So I'm going to write down this as my answer, but I'm going to give it to, according to what the question wants, I'm going to just give it to 3 significant figures for the coefficient. So is going to be negative 84.5 plus 78.1, then ln x. Okay, so this is my answer for part 6. Next, let's take a look at another one, question number 9. So now question number 9. In each batch of manufactured articles, 5% of the articles are found to be defective. A quality inspection is carried out by checking samples of 20 articles. If part 1, let's do part 1. So in part 1, if 2 or fewer defective articles are found in the sample of 20, the batch is accepted. Find the probability that the batch is accepted. We are looking at a binomial probability distribution. Let me define the random variable. I'm going to let x. Okay, I'm going to let x be the number of defective articles out of 20. And x will be following a binomial distribution. Out of 20, the probability of an article being found to be defective, according to what the question says, is 0.05. It is this 5%. And what we are required to find is the probability such that there are going to be 2 or fewer defective articles. So x is supposed to be less than or equal to 2. We can just press this directly into the calculator. It is equal to 0.925. Part 2. Find the least value of n such that the probability of having less than n defective articles in a sample of 20 is greater than 0.99. So we are looking at the probability that the number of defective articles is supposed to be less than n, and the probability of this is supposed to be bigger than 0.99. And because of the restriction of my calculator, we need to make sure that this inequality sign here has an equal to. So we're going to scale this downwards. Okay, so it is the same as x is less than or equal to n minus 1. This is bigger than 0.99. Just to make sure that this is clear to you guys, let's use a numerical example to look at a situation that is like this. For example, x being less than 3. If I were to press this into the calculator, how am I going to do that? I'm going to press this as probability of x is less than or equal to 2, right? We will be getting 2 as 3 minus 1. So that's what I'm trying to do here. If it is supposed to be strictly less than n, for what that is achievable using my calculator, I will have to go for a n minus 1. And we're going to try to press this into our calculator. And I'm going to press it into y1. So we're going to trigger binomial distribution. Binomial distribution, it is here. We are going to go for binomial CDF, binomial cumulative density function. The number of trials here is 20. Probability of success that we're talking about here is 5%, so 0.05. And the value of x is this. It is supposed to be less than n minus 1. So here is going to be x minus 1. And we're going to paste this in our y1, and we're going to try to generate a table. So in the table that we are looking at, let's scroll down a little bit more. We are looking at something that is supposed to be bigger than 0.99. So it is still not more than 0.99. And here we go, we see something that is bigger than 0.995. Okay, let me write this down in my solution. So we are looking at n, which is going to be x over here. And y1 represents the probability of x being less than or equal to n minus 1. Let's list down 5 of the results. The one that is before, the one that is the number that I'm going to be choosing to answer my question, and the one that is after. The one that is before indicated this to be 0.98. 0.9841. And this is not bigger than 0.99 yet. The other one is 0.9974, and now this is bigger than 0.99, and here is a 0.9997. So 5 is going to be what we need because the question asks for the least possible value of n. So this is the least possible. The rest are all going to be bigger than 5 already when we get probabilities to be bigger than 0.99. Therefore, from here, the least possible n is going to be equal to 5. Next, in part 3. Let's do it here. In part 3 of this question, we are looking at 20 samples of this. Okay, 20 samples of this. We want to find the probability that the average number of defective articles per sample is at most 1.25. So this is a sampling theory kind of question. We are going to be writing down X bar, okay, because we are looking at the average number of defective here. Okay, we are looking at the average number of defective articles in these 20 samples. So one sample, it is going to be X. So we are going to be looking at the mean of the 20 samples. So X1 plus X2 plus X3 all the way until X20 divided by 20 is what we are looking for in this question here. So we're going to try to work out first probability for this, okay? So it's not 20 articles. We are looking at 50 samples of this. My mistake again. So the question says 50. So we are looking at 50 samples of this 20 articles. Okay, so we are looking at 50 version of this, not 20. So let me correct this. So we are looking at 50 samples of this. So X1 plus X2 all the way to X50 divided by 50. And 50, this is a large enough number, so we can actually apply the central limit theorem to combine this together and approximating this to a normal distribution. So let's do that. So in order for us to write down the sample mean distribution, we do need the expectation of X. And the expectation of X is going to be N times P. So it's going to be 20 multiplied by 0.05. Expectation of X, we will be getting here 1. And we do need the variance of X also. The variance of X is N times P times Q, where Q is 1 minus P. So N times P times 1 minus P, so it's going to be 20 times 0.05 times 1 minus 0.05. This is equal to 0.95. And since we are talking about a situation where N, which is equal to 50, we have 50 different samples of 20 articles. So this is large. So we can then write down this, which is, we can use the notation X bar. This is going to follow a normal distribution with the mean, which is the same as the mean of X. And the variance of X bar is going to be the variance of X, 0.95 divided by the sample size. And this is by the central limit theorem, where it helps us to get an approximate distribution, which is in terms of a normal distribution. So the question is requiring us to find the probability where this average is at most 1.25. So this average here is at most 1.25. I'm going to just press this into my calculator with the lower limit as negative E99 or negative infinity, upper limit as 1.25. The mean is going to be equal to 1. The standard deviation is going to be square root of this entire thing. Pressing into my calculator, I'm going to get my answer here as 0.965. And part 4, we should have enough space. It is proposed that a smaller sample is going to be taken for inspection. Find the largest value of K such that K is the sample size. So find the largest possible value of K such that the probability of having at least one defective articles in a sample of K articles is going to be less than 0.4. So let me define my random variable again. Okay, in fact, it is very similar to this except that it is going to be now out of K. So we're going to let Y be the number of defective articles out of K. So we're looking at Y to be following a binomial distribution of K and 0.05. And according to what the question says, when the probability of Y is have at least one defective, the probability of having at least one defective article, so bigger or equal to 1, this is to be less than 0.4. So in order for us to press into our binomial distribution, once again, just like what we look at here, it must be, the inequality sign here must be less than or equal to, so we are looking at something that is less than or equal to 0. Right, as in like 1 minus the probability of, because we cannot go for bigger or equal to, so I need to go for the complement of this. The complement of this is for y to be less than or equal to 0, but y cannot be less than 0 anyway. So we are going to just go for a 0 here. Okay, so 1 minus probability of y is equal to 0 is the same as probability of y is bigger or equal to 0, and this is supposed to be less than 0.4. And we're going to try to press this directly into the calculator. Let's try it together again. So my calculator, y equal, let me remove this. We are going to go for 1 minus binomial distribution. This time I'm going to go for binomial PDF. So for here, number of trials is an unknown. I'm going to go for k. This is going to be equal to 0.055%. And the x value that I'm looking for is 0. Let's do a quick check. Binomial PDF, because this sometimes can be a mistake that we have made, that we will make in the exam. Sometimes PDF and we press for binomial CDF and vice versa. So let's paste it here and let's generate a table again. And what we are trying to look out for is for the probability to be less than 0.4. And all these probabilities are so far that is appearing here, right? Y1 is the probability. So far, all of them are less than 0.4. Let's see when we are going to get something that is more than 0.4. And we are getting something that is more than 0.4 here. Okay, and we are looking for something that is less than 0.4. So this is still less than 0.4, and this will give us the largest possible k. So let me write down let me draw the table also. So the x that is there is going to be representing k, and the y1 is representing 1 minus probability of y is equal to 0, which is this that the question is asking for, bigger or equal to 1. So according to the information that is given, when k is equal to 8, the probability is still less than 0.43366. When it is 9, this will be still less than 3698. And when it is 10, it starts to get more than 0.44013. So from here, we can then conclude that the largest possible value for k, this is equal to 9. Let's go back to the question paper. And let's check out question number 10 over here. Okay, in question number 10, we are letting x be the mass of a randomly chosen frozen chicken, and we are letting y be the mass of a randomly chosen duck. And according to the question, the masses are going to follow a normal distribution according to this table over here. So x, according to this table, will be a mean of 1.5 and a standard deviation of 0.3, which means that the variance is going to be 0.3 square. For y, here is going to follow a normal distribution with a mean of 2.6 and a standard deviation of 0.5, so the variance is equal to 0.5 square. Part 1, we want to find the probability such that a randomly chosen frozen duck has a mass which is more than twice that of a randomly chosen frozen chicken. So we are looking at the probability that y is bigger than 2x. Okay, this is fine. The problem is only that we cannot press this into our calculator based on the information that is given and based on the restriction that is imposed to us by our graphing calculator. So to work this out, we're going to try to bring everything over to the left-hand side, or we can also try to bring everything over to the right-hand side. I'm going to go for the left-hand side. I'm going to move everything over to the left-hand side, which then I can apply the linear combination of normal distribution to continue with this. So I'm going to try to find out what is the distribution for y minus 2x. First, I need the expectation of y minus 2x. And this is the expectation of y minus 2 times the expectation of x. So it is going to be the expectation of y 2.6 minus 2 times the expectation of x, which is 1.5. This is equal to negative 0.4. So what we are trying to find is the distribution for y minus 2x. So let me just write it down here also, okay, as our reference. So this will be a normal distribution which has a mean that we have calculated now. It is 0.4, negative 0.4, and we need the variance of y minus 2x. So this is going to be the variance of y minus become plus 2 square, the variance of x. So we have a variance of y which is equal to 0.5 square minus 2 square, the variance of x, this is 0.3 square. This is equal to 0.61. So here is 0.61. I'm going to press this into my calculator now with the lower limit of my calculator as 0, upper limit as positive infinity or E99. Mean is going to be negative 0.4. Standard deviation is going to be square root of 0.61. Pressing this into the calculator will get me a 0.304. Next. Part 2. For this part 2, okay, the frozen chickens are going to be imported at a cost of $6 per kg. Let me write this down for myself. So this is going to be $6 per kg, and x is going to be in kg, right? Is x in kg? According to the question, the weight is, the mass is going to be in kg. It is written for us here. The mass is going to be in kg. So $6 per kg, and the frozen duck is going to be costing $8 per kg. So this one is going to be $8 per kg. We are going to be looking at 100 frozen chickens and 50 frozen ducks. And this supplier is going to be ordering this number of frozen chickens and this number of frozen ducks. We want to find the probability that the supplier is not going to be paying more than $2,000 for this consignment. So we are looking at the total. I'm going to let the total be T, okay? The total is going to be the total cost that is going to be purchasing 100 chickens and how many? 50 ducks. 100 frozen chickens and 50 frozen ducks. And for 100 chickens, the total mass is going to be x1 plus x2 plus all the way until x100. And it's going to cost $6 per kg, so it's going to be 6 times of this. And as for the frozen duck, we are talking about $8 per kg, and we are looking at 50 frozen ducks. So it's going to be y1 plus y2 all the way until y50. So the total cost that the supplier is supposed to be paying is going to be this. We're going to try to work out the distribution for T. Okay, so we're going to find the expectation of T, and this is going to be 6 times of 100 of expectation of X plus 8 times of 50 times of expectation of Y. So this is going to be 6 times of 100 of expectation of X, that is 1.5, plus 8 times of 50 times expectation of Y, this is 2.6. So the expectation of T is 1940. We are going to do likewise for the variance. So the variance of this 6 variance going through variance is going to be 6 square. We have 100 versions of this, so multiply by 100 the variance of X plus 8 is going to become 8 square. We have 50 versions of this, so 50 of the variance of Y. So we are looking at a 6 square multiplied by 100 times the variance of X, then 8 square times 50 times the variance of Y. This is 0.5 square. And the variance of T that we're going to be getting is 1124. So based on this, we know T is going to follow a normal distribution with the mean as 1940 and the variance is 1124. And we are going to make sure that this total amount that the supplier is paying is no more than 200. So this must be less than or equal to 200. Sorry, not 200, 2000. That's a good deal. Okay, anyway, it's supposed to be less than or equal to 2,000. So the lower limit is going to be, I'll press this into my calculator. The lower limit is going to be negative infinity. Upper limit is going to be 2,000. Mean is going to be 1940. And the standard deviation is going to be square root of 1124. And my answer here is 0.963. And this question actually asks for one more thing, which is for us to state an assumption that is needed for our calculation. Since we are combining the masses of the chickens and the masses of the ducks together, what we are going to do is we need to make an assumption. Since we are doing this linear combination, in order for any of the linear combination to work, whatever that we try to sum together, they must be independent of each other. Okay, but we want to be a little bit careful because a very common mistake that I can foresee for a question that is like this is for students to simply say that, oh, the masses of the chicken is independent to the masses of the duck. Okay, or even worse, the mass of a chicken is independent of the mass of a frozen duck. Okay, or frozen chicken, a frozen duck. Well, this is incorrect because we are not just combining one single x and one single y. We are combining more than one x, multiple x and multiple y's together. So we need to say that everything, okay, even amongst x and amongst y, everything, they must be independent of each other. So I'm going to write down a version that is something like this. Okay, a version that is like this, highlight all, okay, not just a single chicken, not just a single duck. It is all the chicken, all the ducks, they must be independent of each other. Let's look at part 3. Okay, in part 3, we're going to let W be the purchase price of a frozen duck. Okay, this is the selling price. Okay, so the purchasing price wise, according to what the question says, the purchaser, which is the restaurant owner here, will be paying for a 25% profit going to the supplier. So 25% more than the cost of a randomly chosen frozen duck. So W is going to be equal to, for the cost of a randomly chosen duck, it is going to be 8 times of Y. And we are going to go for a 25% profit, right? So we will multiply this by 1.25. This will make sure that the purchase price of the duck gives the supplier a 25% profit because 8Y is a cost to the supplier. So from the cost, we are going to add a 25% to it, 1.25. So W is going to be equal to this. W is going to be equal to 1.25 times 8. W is going to be equal to 10Y. So the expectation of W is going to be 10 times the expectation of Y. This is going to be 10 times of 2.6. This is equal to 26. And the variance of W is going to be equal to 10 squared the variance of Y. So it's going to be 10 squared, the variance of Y is 0.5 squared. This is going to be equal to 25. This tells us that W will follow a normal distribution with a mean of 26 and a variance of 25. And it is given to us that there is a probability of 0.7 that this restaurant owner will be paying between $20 and A. So the probability that the W here is between 20 and A. This is a probability of 0.7 and we are supposed to, based on this information that is given, to find the value of A. So in order for us to try to look at this and look at this information that is given and try to find A, we're going to make use of using a bell curve and looking at the area under the bell curve to represent the probability that is given. Let me draw in this bell curve into my solution here, okay? So we are looking at this bell curve where it is meant for W. And here we have a 26. 20 is less than 26. Let's say it is here. A, I'm not very sure where it is. But since this is equal to 0.7, which is bigger than 0.5, A must definitely go beyond this. Okay? Because from here to here is 0.5 already. So A is beyond this. Let's say A is here. Okay, so this area that we are looking at here, this area is equal to 0.7. So in order for us to be getting this area, it is the same as looking at the area that is less than A, or this part, minus away the area that is less than 20. This is equal to 0.7, which means that the probability that W is less than A is going to be equal to 0.7 plus the probability that W is less than 20. And we can actually find out what this is, right? Okay, I just need to press it into my calculator, 0.7. The lower limit is going to be negative E99 or negative infinity. Upper limit is going to be 20. The mean is going to be equal to 26. And the standard deviation is going to be square root of 25, which is 5. This is going to get me a 0.115070. So probability of W is less than A is going to be equal to 0.81507. And we can press our calculator again to get A. From our calculator, A is going to be equal to 30.48. We're using 2 decimal places because A is supposed to be money. So A is going to be equal to $30.48. Let's move on to the last question. Last question is question number 11. Here we go. Is this the last question? Yes, this is the last question. So let's take a look at question number 11. So in part 1 of question number 10, we are supposed to carry out a 10% level of significance for the information that is given to us to check whether the goggles that is going to be given to George is going to help him to swim faster. And this is the definition that I have, this is the definition for the symbol that I've been using, and we should state the hypothesis. So for the null hypothesis, according to the information that is given to us by the question, the population mean is 120.05, and we are supposed to be testing whether it has helped George to swim faster. So the time that we are looking at should be shorter, so mu is going to be less than 120.05. Okay, he is swimming faster. The sample size that is given to us, we are looking at a random sample of 50, and the sample mean, okay, we're going to make use of this information here. This is the consolidated data, the summarized version for the 50 random sample that is recorded. So this is going to be sum of t minus 1 to 0.05 divided by n plus 1 to 0.05. We are using the extended formula that is in our Achevas TV outline. So this is going to be equal to negative 66.4 divided by n, which is 50, plus 1 to 0.05. This is equal to 118.72. This is going to be this, and we are going to try to state the test statistics. Okay, so for the test statistics, since n, which is equal to 50, is large, we can write down t bar, which is going to be t1 plus t2 all the way until t50 divided by 50. T bar is going to follow a normal distribution with a mean of population mean, 1 to 0.05, and a population variance. Let's take a look at the question again. Do we have the population variance? We don't have the population variance. So we are going to try to calculate for the population variance by doing an estimation based on the sample that we have, based on the samples that we have recorded. So we are going to calculate, we are going to compromise and calculate for the population variance by approximating it based on the unbiased estimate to the population variance. So this is calculated as 1 over n minus 1 summation of t minus 1 to 0.05 square. Again, we are using the extended formula that is inside our Achevas TV outline. Then summation of t minus 1 to 0.05. I'm going to square this whole thing divided by n. So this is going to be calculated as 1 over 50 minus 1 multiplied by this is 1831.945 minus away this square, negative 66.4 square divided by n, which is 50. So this is getting me a 35.587. So we have this. Now here will be the population variance, which is this 35.587 divided by n, which is 50 over here. And this can be done through the central limit theorem. So this is an approximated version. And the reason why we are doing a central limit theorem is because the question didn't actually mention to us whether t here follows a normal distribution. So we do need this central limit theorem. And let's write down also the standardized version for this, which is z is going to be t bar minus 1 to 0.05 over the square root of 35.587 over 50. This follows a normal distribution of 0, 1. It's not a very meaningful part of my solution, but I think as a template, from the perspective of a template, I think quite a few schools, they are doing this. So I'm going to write this down also, okay? And based on this information that is given, we are going to try to plug it into our calculator to get the p value. So from our calculator, we're going to try to find the p-value. And let's try it together. So on our calculator, we're going to press stats and we're going to go for test. So in test, we are going to try to press the z-test. And let's go for statistics here. Mu is equal to 120.120.05. And for sigma, I'm going to be pressing in the standard deviation of the population, so it's going to be square root of this. So here is going to be square root of 35.587. So we have this, and x bar, which is the sample mean is going to be this. So 118. Let me press it in. So here is going to be a 118.72. Okay, and the sample size is 50. We are doing a left tail test. Let's take a look at what is the p-value. So let's do a calculation. P-value is going to be equal to this. So p-value is equal to, according to what we have here, 0.0575. Okay, we have a p-value that is this, 0.0575. So we have a p-value. And from this p-value, we are going to compare it to the level of significance. So since this p-value, which is 0.0575, when we compare it to the level of significance, which is 10%, this is less than 0.1. So since p-value is less than 0.1, therefore there is sufficient evidence that George is swimming faster at 10% level of significance. And part 2. Part 2, explain why this test will be inappropriate if the sample size is 10. Of course, it is going to be inappropriate because we need the central limit theorem. If you were to look at the question didn't actually tell us that T follows a normal distribution. And if we want to carry out a z-test, we need a normal distribution. And if the sample size is small and the distribution of t is unknown, we cannot carry out this test at all because we cannot assume t to become a normal distribution. So that's the reason I'm going to be writing down here. Okay, so this is my explanation, which is like what we have just mentioned. We need the sample size to be big in order for us to apply the central limit theorem. And since now the sample size is just 10 and we don't know whether George swim times follow a normal distribution, we cannot approximate and get a normal distribution for our test statistics, and that is why we are not able to carry out this test that is required of us. And in part 3, explain in the context of the question what is 10% level of significance. This is easy. Let me write it down here. So in part 3, this is my answer. It means that the 10% level of significance is the probability. It means that there's a probability of 0.1 that we conclude wrongly that the mean swim time is going to be less than 120.05 when it is in fact 120.05. Okay, let's move on. Let's take a look at B. So in B, we are now given X as one that follows a normal distribution with a mean of mu and a standard deviation of sigma. So the variance is sigma square. And n, we are looking at n samples of this X, and n is sufficiently large, but we don't really need that because we already know X is a normal distribution. So if you are going to be carrying out a hypothesis test, X bar can already follow a normal distribution. For the sample, the mean of this sample is K and the variance of the sample is 9. And a 1% level of significance in part 1. A 1% level of significance is being carried out, and the null hypothesis, let me just write down the information as we read. The null hypothesis is equal to 25, and the alternative hypothesis is going to be not equal to 25. So we are talking about a two-tail test, and that is given to me is n. So n is just n, and x bar, this is given to me as k, like what we have mentioned just now. And the population, not the population, the sample variance is given to me as 9. Okay, take note, this is the sample variance. And based on this, we can actually try write down the test statistics first. The test statistics is going to be X bar, which will follow a normal distribution with a mean of 25 and a population variance. Okay, again, just like part A, we don't know what is the population variance. So for population variance, we're going to try to estimate it based on the unbiased estimate of the population variance, and we're going to make use of the sample data. So it's going to be it's going to be n over n minus 1 multiplied by the sample variance. Let me just rewrite this. This is equal to n over n minus 1 multiplied by the sample variance. So it's going to be equal to, n is n, so n over n minus 1 multiplied by 9. So 9n over n minus 1. So the test statistics will have a variance of 9n over n minus 1 divided by n. Okay, please take note, we don't write the by CLT here because we don't need to apply the central limit theorem since x is already given to me as a normal distribution. So x bar here will follow a normal distribution of 25 and a 9 over n minus 1. Okay, just a quick simplification of this. And according to what the question says, H0 is going to be rejected, right? The question says this. The null hypothesis is going to be rejected in favor of the alternative hypothesis. So to reject the null hypothesis, reject H0, what we are talking about is, let us just try to reference it to our test statistics here, okay? So when we have our test statistics, X bar here, this is 25. Okay, and we are talking about a 1% level of significance. So for a 1% level of significance, we know that this area here is 0.01 divided by 2. This area here is also 0.01 divided by 2. And since the null hypothesis is going to be rejected in favor of the alternative hypothesis, we know where is X bar, which is this K here. So K can be either residing here, K can be here, or K can be residing here. So it is going to be here or here. Okay, of course, K cannot be at both ends, but it is going to be either residing here, which is in the critical region, or going to be residing here. And we are supposed to, in part 1, find the range of values of this K. And I don't think we can work out much from this because there are too many unknowns in this. So when there are too many unknowns in our test statistics, what we can try to do is to do a standardization, because once we standardize, the distribution becomes 0, 1, and that makes it possible for us to be pressing it into our graphing calculator. So let's try to standardize our bell curve. So when we standardize our bell curve, X bar will become Z, and Z will follow a normal distribution of 0, 1, correct? So for Z, here will become 0. We are still talking about the same level of significance, and with a two-tailed test, it is still 0.01 divided by 2, and it is still 0.01 divided by 2. And K is going to be standardized, and it's still going to be falling within the critical region. So when we standardize K, we will have a K minus away the population mean divided by square root of 9 over n minus 1. The same goes for this. Let me just rewrite this, okay? So K minus 25 over square root of 9 over n minus 1. So the standardized version for K is going to be this. And what we are going to try to do is to find these two values here, this value and this value. Let me just call this Z critical. And since these are symmetrical to each other, this must be negative Z critical, correct? It's very, very easy for us to find Z critical because the probability when Z is less than this Z critical is supposed to be equal, negative Z critical. This is supposed to be equal to 0.01 divided by 2. So we can actually press our calculator to find what is this negative Z critical. And based on our calculator, this is negative 2.5758, which means that Z critical is going to be equal to 2.5758. Let me just erase this and replace it with the actual numbers, okay? So negative Z critical is this, negative 2.5758. 2.5758. And Z critical here is 2.5758. So now this is very clear to me now, because this number must be less than this in order for H naught to be rejected. So therefore, K minus 25 over square root of 9 over n minus 1, it must be less than this negative 2.5758. Or, because we cannot have K at both sides at the same time, so it is not an n, or K minus 25 over square root of 9 over n minus 1 must be bigger than positive 2 minus 2.5758. And if I were to try to work out this value of K, I'm going to leave it to you guys to just do the details here, okay? This K here is going to be less than 25 minus 7.7275 over square root of n minus 1, or K is going to be bigger than 25 plus 7.7275 over square root of n minus 1. And this is my answer for part 1. And in part 2, we want to state the conclusion for the hypothesis in a case where K is equal to 24 and n is equal to 42. So if that were to be happening, let me erase this here. Okay, what we can see is that in order for H naught to be rejected, okay, I'm doing part 2 now, okay. So, okay, let me just write it as if it is part 2 here, but let's go through the thought process. In order for H naught to be rejected, we need K to be less than this. So in order for H naught to be rejected, K should be less than 25 minus 7.7275 divided by square root of n. In this part 2 here, n is given to us as 42. So it's less than n minus 1. So 42 minus 1, or K must be bigger than 25 plus 7.7275, then divided by this square root of 42 minus 1, which means that we are looking at K to be smaller than, this number here is 23.793, or K to be bigger than 26.207. So in this question here, in this last part of the question here, it is given to us that what if K is equal to 24? What kind of conclusion can you make? So I'm seeing 24 as neither less than this nor bigger than this, which means that H naught is not going to be rejected. So that is exactly what I'm going to try and write. So since K, which is equal to 24, is neither less than 23.793, nor is it bigger than 26.207, so we cannot find sufficient evidence in order for us to be rejecting H naught at 1% level of significance.